Assalamualaikum and hello everyone. In this video, we will be presenting about our workshop project, which is Turbine Blade V3 for our course MEM360. This is the list of content that will be presented by us in this video. The first one is introduction. The second one is safety equipment and technique. The third one is manufacturing step process. The fourth one is the problem faced and overcome, and the last one is discussion. Our group members consist of 4 persons. The first one is Amirul Haziq bin Saiful Azhar. The second one is Muhammad Adri Firdi bin Aidi Razi. The third one is Muhammad Aiman Mustaqim bin Azman, and the last one is Luqman Hakim bin Muhammad Maryadi. This is our group's work distribution among group members. For example, Muhammad Adri Firdi was in charge of operations such as cutting using the bandsaw, milling, drilling, welding and grinding. He also handled the video part for the work distribution and introduction. The second one, Luqman Hakim, focused on land operation, bandsaw cutting, drilling and grinding. For the video, he explained about safety equipment and proper techniques used during the process. Amirul Haziq also contribute to workshop process including cutting, milling, drilling, welding and grinding, and he also create the video on the manufacturing steps involved. Lastly is Muhammad Aiman Mustaqim, handled the lead drilling, welding and grinding operations and took care of the video that discussed the problems faced during the project and how we overcome them. In conclusion, each team member played an important role based on their strengths, which helped our project move efficiently and successfully. The next one, we go for introduction. The Turbine Blade V3 project is part of the MEM360 workshop course designed to enhance students' practical skill and understanding of the complete manufacturing process within a real-world engineering context. This project challenges students to plan, fabricate and present the development of a turbine blade using a variety of machining techniques including bandsaw cutting, milling, blade turning, drilling, welding and grinding.
Now, I will talk about the safety equipment and the technique that we are using in this project. First of all, safety equipment is very important to prevent any injuries and accident, because working with a machine like welding, drilling and machine involve the sharp tool, high temperature and fast moving parts. Without a safety equipment, accidents like cuts, burns or even serious injury can happen. First of all, I will start with the drilling machine. For this machine, we are using a safety goggles and glove. For what? To protect our eyes from the debris and to handle the sharp edge. Debris is the smaller, broken pieces of the material. For milling machine also, almost the same of the drilling, which is we are using a safety goggles and glove to protect our eyes from the injuries from the chips and to protect our hand from the sharp edge. For the lathe machine, we are using goggles to protect the eye from the flying pieces of the metal. So, this is the situation when we are handling the lathe machine. For the welding part, before start the welding, we need to use the helmet welding and glove to protect the eye and the face from the arc flash and protect the skin from the burns and the molten metal. Now, I will talk about the technique that we are using during this project. For the measurement, we have two types, which is linear measurement and angle measurement. For the linear measurement, used to measure length, width and height and diameter. For the angle measurement, used to measure the angle of the workpiece. For the milling machine, use a rotating cutting tool to remove the material from the stationary workpieces. In this project, we need to get 3 slots for the workpieces. Basically, to using mini machine, we use X-axis, Y-axis and Z-axis. For the X-axis, move the table from the left and right. For the Y-axis, move the table forward and backward. And for the Z-axis, move the table for up and down. Next is a lathe machine. Lathe machine used to rotate a workpiece while cutting tool to shape it. The technique we are using is facing and turning. So this is the process that we are using lathe machine to get the measurement we want. Basically, based on the video, we need to get 27.5 radius of the workpiece. Lastly, for the welding technique, we are using the spot welding. Spot welding to join 2 or more metal sheet at a specific point, and the type of the welding we are using the metal inert gas, which is MIG.
After that, I want to discuss the steps that need to be taken from the start of the project until its completion. In order to facilitate the process, a group first determines and comprehends all of the dimensions needed for each component before entering our workshop. We will divide the activities and measure the provided parts during the first week of the course. In accordance with the measurement provided in the working paper, we will first confirm the length and width of each component before taking the measurement required to ensure the success of the product. Once the measurement will finish, we cut using the Gegas laboratory equipment including a handsaw in accordance with the specification. In order to make cutting the 3 tiny pieces easier, we headed to the milling lab after determining that using a handsaw was challenging. The following week, we measured 3 drains for both workpiece and 2 square workpiece to drill in the gas laboratory. As part of our compliance with safety rules throughout the milling process, we made sure the workpiece were extremely tight before milling in order to create drains for the second workpiece. Additionally, we separate into the 2 groups at the same time, with some making it in the lathe laboratory and other in the milling laboratory. Another group at the lathe lab was tasked with creating a cylinder that will be placed in the center of the box. Before beginning the procedure, the workpiece in the lathe lab needs to be tight and the tool post eye need to be in the center of the cylinder to guarantee an even cut. The tailstock can be used to align the tool post location, and it takes a few weeks to complete this process. Once the milling laboratory operation is finished, we go back to the quick laboratory to tap the screw hole. We return to the lathe lab to manufacture rounds for the 2 square workpiece after finishing all the procedure. It needs to be fastened to a specialized tool before being made spherical. It must then be made tight, and the longest corner must be found before cutting begins. In order to prevent the tool tip from being broken or damaged, the cut must be made carefully and consumed gradually. The machine must be slow and not too fast when cutting the tools. All the components are linked once the rounding is complete, and then they are transported to the welding lab. Certain components like cylinder and the round workpiece are welded at the welding lab to make sure the cylinder doesn't move or rotate when spot weld. To make sure the parts are attached and immobile, we then weld in the inside of the drain hole and the 3 sections. Finally, we proceed to the Gegas laboratory to complete the welding process to obtain the clean surface for the leftover weld after welding. We use a grinder to remove it.
Next is the problem faced and ways to overcome for this project. Here are the list of the problem faced during the project. The first one is the incorrect cutting. The second one is the drilling inaccuracy. The third one is milling angle misalignment. The fourth one is the turning miscalculation. And lastly, the fifth one, fitting issue on the workpiece. First of all, let's talk about the incorrect cutting. Throughout the measuring process, there's a slight misunderstanding that led to wrong markings on a plate. Because of this, a plate was cut by following the wrong markings. The plate should not be cut in the first place. Therefore, It was the reason why the plate was bigger than the other one. These are the ways to overcome this problem. Although the dimension of both plates are different, we continued to progress. Because a plate is smaller, some measurements need to be remade. Both plates can still be shaped together during the turning process. The second problem that we faced is the drilling inaccuracy. During the drilling process, the workpiece tend to move due to the vibration. This made the workpiece difficult to drill. As a result, the dimensional accuracy will be affected if it is not properly secured. Due to those problems, we decided to let more members help during the drilling process. The other members help the process by holding the grip of the workpiece together to keep it in place. The third problem that we faced is the milling angle error. During the milling process, the milling angle was off due to a wrong assumption. This caused one of the slots to be misaligned from the other slot. Therefore, one of the parts that should be fit was not fit. And the ways to overcome this problem is to redo the milling process by calculating the angle again before starting to mill. Next one is the fourth problem that we face, which is turning error due to the wrong assumption. In the turning process, one of the part was cut incorrectly. The part that was cut incorrectly has the wrong length on both ends. Therefore, the part should be cut by following the procedure. But because of a wrong assumption being made, both ends do not have the same length. Here are the steps to overcome this problem. We decide to reduce the length of one end to obtain the same length. Therefore, the total length of the cylinder will be shorter. Although the total length of the cylinder was shorter, the piece still can fit in the plate but with a shorter length. The last problem that we faced is the fitting issue on the workpiece. Before the assembling phase, we make sure that the parts fit perfectly with each other. We found out that the diameter of the hole was not a fit for the cylindrical part. This caused the cylindrical part to not penetrate through the hole. Therefore, we come up a solution for this problem. We decide to reduce the diameter of the cylindrical and file the hole to remove the excessive chip inside the hole. After that, we try to fit the cylindrical part to make sure it fits the hole or not. And for the last one is the discussion for this project. There are several improvements that can be made. The first one is the time management. The time management for each process can be improved by perfectly plan the process that will be performed. The second one is carefully measure and assume the dimension that needs to be cut, mark the right length and angle truly, and use any reference or pattern that can be obtained by using any paper to reduce the workload. And lastly, enhance the distribution of work among members. With a good work distribution among members, it could increase the production rate of the product. And that is all from this video. Thank you for watching.